Hello, hello, hello. So we are back after a break. I went on a trip with family and family. It reminds me of Dominic Toretto of the Fast and the Furious franchise. Uh, and we are back to this. So what are we doing? Striver DP? Yeah, Striver DP. And I'll, I'll see. We'll see. I'll see. We'll see. Shortest common super sequence. Shortest common super sequence. Okay, so how will we do shortest common super sequence? It will be a problem of LIS, longest common subsequence, I think. Because I think all of them were LIS, that's why. Uh, let's see what's the question. Given two strings S1 and S2, return the shortest string that has both S1 and S2 as subsequence. If there are multiple value string, return any of them. If string is a subsequence of ST, I think some. Okay, cool. So C A B A C C A B. Okay, cool. Now the string that is the longest common substring sequence is not part of the answers. That is okay. That is what I understand. Uh, how will I do this? So if we take this, AB is the longest common subsequence, and C is in front of this, AC is in front of this, back of this. So what if it was BAC? In that case, also CB or BCABAC would be the answer. Okay. How can I do this? So how can I create this super sequence? When I Now A and C don't match. So there will be one case where I let's write something. Let's see. It's really wrong. BAC AB. At the start, A and C don't match. So in that case, what we do? One case would be to move ahead with A. Hmm. So ABAC, ABAC, and this will be AB. Okay, and whatever the answer, I add C to it. Cool. In this case, see, a basic solution would be find the LIS. Okay, the basic solution would be to find the LIS and then find the LIS in both of these strings and then add all the letters that are in front of the LIS to the front of the string and then to the back of the LIS in both of the string to the back of the string. That would be the basic way I would do this, but I'm not getting. Let's look at one. Yeah, that we can do. LIS we can find. How do we find? How do we do calculate those? Okay. Okay. This is interesting. So what they are doing? Huh? Hmm. Vector string, vector of string. We can find LCS using this. This is interesting. Firstly, they are using the deep top-down version of LCS. So yeah, LIS, LIS. I need to see this. Insertion. Longest comma, longest span, long comma substrate. How was this done? Print longest common subsequence. Because if this is the case, I think we can do print longest common subsequence by this only. Okay, this is the way to print it, basically. Let's BBA. But this only gives one to us. We want multiple here, so that was the issue why we can't do this. I get that. Okay. Here we only need one. Right. Oh, string B, we take two string in the LCS function, and n is equals to a dot size and is equals to b dot size Net of vector of size plus 1. For loop. If both of them are equal, then in that case, we just do dp of ij plus dp of a of I or b of I. If both of them are unequal, then check the size of the upper and lower arrays. Cool, I understand this. My logic was similar. I did not know how I would code this, but okay. I think does not work. Okay, so first thing we do is create a table where is compute LCS. Gee, Okay. Are we even computing LCS? Oh, be right back. Cool, 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 cool. Oh, God. So basically, we calculate the LCS. Then, if the letters are equal, then obviously we push back the rest. If they are not, then we find out where the LCS is the largest, and then we push that one to the rest. I think that is the case, which does make sense. Uh, distinct subsequences. Given two string, write down the distinct subsequences of S which equals to the test case only. R A double B I T R A double B I T. Basically print the longest subsequences. This is the same question, it seems like that. Because BA and is also a subsequence, but it's not the largest. We only need to print distinct largest subsequences. It seems like that. And I think that's basically we find the LCS and then we find the subsequences of that size. Or we can, yeah, we find the LCS of that size. Yeah. Do this. Oh, case question. Huh? What am I doing? Oh, we have to only print. Okay, it's not print. It's actually the number. I thought I'm not reading, which is a bad thing. Why J is equals to S equals to M, I return 1? Why is that the case? Because, okay, the entire string has been traversed. Okay, so when this gets traversed, we have our answer. When this gets traveled, J is already is left, so we don't have an answer because we are. only focusing on I. Cool, I get this. Now let's write the top-down version of this. Yep, this works. We have the base case done. Now, copy this. I plus 1, J plus 1. So memo of 0, comma 0. And we heard wrong answer. What's my? I'm just prepping for an interview, and I thought I should stream also. It's just uh, a way for me to learn to speak while coding. So just that. So I have an interview, and that's why like I'm doing this. So it's and Mang is Meta, Apple, Amazon, Netflix, and Google. So I have an interview, and that's what I'm doing. Nothing very special. Oh, why isn't this working? Let's just print this on 2nd January. I have my interview on 2nd January. Thank you, bro. Thank you. For NJ, this goes to 0. So we loop from J to M, and let's check out if we are getting a correct base case. So, correct base case, correct. Memo of I, comma J. Let's put the space after the cout, a line break after of 2nd Jan, not Feb. Yes, 2nd Jan, the first round is on 2nd Jan. There is something wrong. So according to this, okay, this should be equals to that's what sort of, and this should come after this. What's the issue? Huh? Is it a problem? I I display capture. Sometimes this Streamlabs creates a problem, like it does not work. Right. Uh, so I wrote a top-down solution. The wrote a bottom-up solution which was working, but the top-down is not working. So that's the issue right now that I'm solving for. This was the bottom-up solution, which was easy. But if I can, I can also do this. If I is equals to if j is equals to m मैं O of I j is equals to 1 if and then I can remove this. If let's see if that works. I don't understand why is this not working. And we can do also continue here. Let's just print this out after we have done. I don't understand. This will go in the else case. Yeah, because I was returning here, so this should have gone into the else case, which I wasn't doing earlier, which was the issue. And but because of this, I understood I could also add the base case to the array itself, and then I will not have to run an extra loop. So it actually saved me from two loops of n and m, which is good, I think. But it also adds these cases on every check. So count your own demons. Choose your own demons. So, huh, let's make it long. Though I don't think we require it, but whatever. What's the answer for this? Hmm. Why is this not working? Why am I getting? So the error is integer overflow. Have they given? Yeah, the answer fits on a 32-bit signed integer. But still, I have a problem, which was not there in the bottom up version, but is here in the top. Why do we have this problem? If it was a problem, it should have been shown here also, but did not affect our code. Would this work? I have to build an answer with both I and J, I guess. Uh, do you guys have any idea why this is happening? So I'll show you guys. It was working for the bottom of version. So if I do solve 0, commas 0, you know, it's working with 69%. But when I write the memoized version, it's not. Hmm. Can you show the definition of MNN? Okay, yeah, M is the size of T and N is the size of S. I was I was away from the Wi-Fi. I think that's why the latency was crazy. Ah, because the definitions. I like defining the variables on the top because it makes it easier to write these functions and then you don't have to pass them and they become global. So low latency later. Is the latency better? Huh, huh, in 64. Well, I've tried changing it to long also, but let's long if I change it to long, which is 20 seconds or 20 seconds. Uh, it gets a bit better, but not that much. Plus, the description says the answer fits 32-bit signed integer. So there's no point of doing this. Unsigned. Unsigned long does work, but why? I don't understand why. Why it works for the bottom up version and it does not work for the top-down version. Why the intermediate in this case is much better than the intermediate in this case. Space complexity is the same, but actual space goes down. After all, but the time complexity will be m into n. The space is m into n. Because of two nested loops, it's m into n. Like this loop goes to n, this loop goes to n. I don't know how to do that. How do you add as a collaborator? Is there a way to do that? I don't know. I don't know, bro, how to do that. No idea. Let me. Ah, I think I'll move on. Let's see if we can space optimize this even more. Yes, we can. We can space optimize this even more as we only use the next array in the series. We can do this. How do we space? We can space optimize it a bit more. So how do we do that? Okay. We store a vector string of this. So the first, the array of uh n would look something like 0, 0, 0, 0, 0, and the last position would be 1. So we create an array of that first thing. So let's make vector of this thing only. Memo 2, uh, memo 2, and how will memo 2 look like? Memo 2 is equals to vector of unsigned long, what will be its size? M plus 1, comma, all of them will be 0. Now The mth position will be 1. I'll show you why it would be 1. So let me just show you this. Why I have done this. If I run this, so we want uh, mhm. This output looks weird. Okay, unsigned long long will be not. We can make it 0 also. That's not an issue. Yeah. Will not work. Ah, obviously, I get why this is getting TIA because of this. But these cases are very tight. But that does mean, okay, this should happen after this. Yeah, now I can show you. You can see after the base condition, it's like 0, 0, 0, 0, and the last one is 1. So that's why I create memo2 like this. Now I can run a loop. Which loop do I eliminate? Do I eliminate the outer loop? Is that the case? Yep. Eliminate the outer loop. J is equals to m minus 1. Y. No, I can't eliminate that loop. I will have to make two if of size 2, I guess. Memo 2 and memo 3. Cool. Now memo 3 of J is equals to memo 2 of J plus 1 plus memo 2 of J. Okay, and memo 3 of memo 2 of J. Okay, and at the end, when all said and done, not inside this loop, outside this loop, memo 2 is equals to mem 3. Now at the end, memo 2 of okay, memo 2, memo 3 of J, memo 2 of 0. Ah, why is this long? Let's just go back. We have memo 2 and memo 3. Cool. Now memo 2 of M is equals to this. Cool. We can leave this out and we can run a loop for in I is equals to 0, I smaller than M, I plus plus more than equals to M, the out memo 2. Okay, let's see. This is correct. 205. Cool. So all zeros and one. I should do this for memo 3 also, I guess. Cool. Now I can remove all these i's. This would be memo 3. This would be memo 2, memo 2, memo 3, memo 3, 2, and at the end, memo 2 is equals to memo 3. Cool. Memo 2 or 3, anyone works here, and it works. Cool. So basically, this thing I missed, memo 3 of m is equals to 1. And now we have space optimized it to m. Can we optimize it even more? Let's see. Let's see, let's see, let's see, let's see. Oh, J is dependent on J plus 1 and J. Okay. Memo 3 of J is dependent on memo 2 of J plus 1 and J. So this could be done on two sizes array also. So 0, 1. This could be 0, 1. After this could be a loop of like a value of 2, I think. Can it be? Can it be? Let's see. Let's see. I think we can do it in a constant space because J depends on J plus 1 and J on J, and J depends on J here also. So if we take this as memo 2 and memo 3 as size 2, so in that case, but that'll be very much more complicated to write right now because then we'll have to rely on mods to make this happen. We can do that. We can. I don't think that is required right now for my preparation. But if anybody wants to try this, they can look into it where this is dependent on these two. So this at the start you can take memo 2 and memo 3 as size of 2, where it's first initialized as 0 and 1, and then you can play with mods to like the modulo operator to find the index for all of them and then like and then make the answer. Let's see if I can remove this after. So I remove this. Let's clean up the code a bit. Let this go. I can let the solve function go because that works. Submit. 89% time complexity, time, like 89% tile, 89% tile. Now, what can I do better on the side of cleanup? Nothing else, I guess. Memory wise, it's also good, 86 percentile. What is this? Yeah. So if I want to space optimize it even more, I can do this where I uh, take memo 2 as memo 2 and memo 3 as array of size 2 and then play with it and good. Like, first time this will be 1 0. Okay, 1 0 and 0. And this will be 0. Wanna try this? Let's take four variables. Int A is equals to 0, int B is equals to 1, int C is equals to 0. Cool. Now this could be C, B, A, A, C. Cool. Now after every round, I do. Uh, let's not do it like this. Right? Let's copy this and then we'll delete. Memo 3 is C. Memo 2 of J is B, A. Cool. C, A. Now after every round, A is equals to C. Oh, yep. So we can remove memo 2 and 3 also. After after all the rounds, let's see if this gives us the right answer. Okay. And now memo 2 is equals to memo 3. So A is equals to C, comma, B is equals to 1. This will reduce this will reduce the disco, and the answer is wrong. Okay, this can be done. I think this can be done, but have to figure it out some way. Let's see. Now C is equals to A is the analog for this. Now once this is done, then after this, what will change? Ah, can this actually be done? Or was it just in my head? No, it cannot because of this actually. Because in the next step, we want the entire array, which is creating a problem. And yeah, it cannot be done. Just I, just a thought that I had, but it can't be done. So this is the best answer, 89, oh, 89, 87 that I can come with, 85, 88, around 80 plus. Uh, let's look at the editorial now. Almost the same. I'm not doing the substring thing, which I think is better. Yep, yep. This is better, I think. DP of IJ, they are directly just hmm, the memo. First thing they are doing this, and then if it is equal, then they are adding this. So I don't think it saves. Yeah, it saves, I guess. I don't know how much it saves. Space optimize. Yup, similar to mine. Oh, they are not actually like I'm better space optimizing than them. Or they are, yeah, I'm better space optimizing them now. Seriously. Where is your single array? You're using two arrays, but not space optimizing it. Like in the code, I don't see you space optimizing it. I don't know, no. Or they have not written that code properly. He forgot to copy paste, but yeah, don't seem like that. This thing, subsequential. Edit distance. I think I've done this before. Let's given two strings, word one and word two, return the minimum number of operations required to convert word one to word two. Okay, yeah. I think this is easy. I remember this question. Insert a character, delete a character, replace a character. Okay. So we are on H and R. If both of them are equal, we move on to the next. If both of them are not equal, in that case, we can either insert a character, we can delete a character, which means insert a character means if we insert in word two, let's say, what convert word one to word two. Okay, we can do the operation on word one. Okay, If H is equals to R, we move on. Okay, no issues there. If H not equals to R, we can insert a character which is basically stay on H. No, move from, move from H. Yeah, so it will come to O, or no. It's not that. Uh, yeah, it'll move from R. So it will move from to O and H will be here because we have inserted a character here. Basically, inserted R. This would become R H O R S E. So, which equals to R. That is one case. They either we can delete H. So in that case, H will move ahead and ORSC ROS would be so I will become one. Or we can replace a character. So we replace this, so we move both of them, and that is the basic case. So I think that's what we do. Yeah. So for when both of them are equal, then I plus one, J plus one. When we insert, I stays the same, J goes ahead. When we delete, I plus one, J stays the same. When we replace, both of them go ahead. And then we take one and we add the min of all of these three. And that is it. I think oh, I've written the top-down version of this also. So yeah, have a space optimized it. Have a space optimized it. Can it be space optimized? No, it can't be space optimized because it's dependent on I plus one and J plus one. So that's why it can't be space optimized. Not only J plus one and not only I plus one. If that was the case, it could have been. And that is it, I think. That's edit distance. Um, I hope I was able to explain it well. Basically, this is how DP works now. Like, if both are equal, then what options do we have? Both are equal. So we just move ahead. If both are not equal, then we have an option to insert. Insert will make, if we insert R in front of this, then they match and then we go ahead for J. If we delete, so if we delete, then I only go ahead. So we come on O and R. I will be on O, J will be on R. If we replace, H is replaced by R. So in that case, both of them go ahead. So that is that, and we take the minimum of this because we want the minimum edit distance, basically minimum number of edits. So that's the case. Wildcard matching. I need to bring my charger. BRB. Charger here only. Ah. Given an input string S and a pattern P, implement a wildcard pattern matching with support for question mark and matches a single character, matches a sequence of character, matches any sequence of character, including an empty sequence. Okay. Okay. Okay, so when we get this, we move I and J both. If I not so base case would be both of them are at the end, then we get true. If any one of them is at the end and the other is not, then we get false. Okay. Now if these both are equal, then we go ahead. If one of the like the pattern is this, then we go ahead. If we get star, then either we can go ahead for S and that's when we will stay on P, we'll stay on the star, or we can decide to not use the star and go ahead for both of them. And that's how we do pattern matching, I think. That's the simple version. Let's solve this. Solve will be a function of int I, comma, int j. Okay. If I if I is equals to n and j is equals to m. In that case, return one if I is equals to n. Return zero if j is equals to m. Return zero. Cool. Now let's match. If s of I is equal to p of j, return s of I plus 1 j solve of I plus 1 comma j plus 1. If they are not equal, then if p so or p of j equals to question mark, then also we'll do the same. If p return 0, at the end we'll return 0, and if p of j equals to star, then we have two case solve. Either we can take the star, use the star, so we can do it like solve of I plus 1 comma j, or we can decide to not use the star. Plus, what do we want? Or and this should work. So G S P and N and M. This dot S is equals to S. This dot P is equals to P, and N is equals to N. sorry, n is equals to s dot size, m is equals to p dot size, and return solve of 0 comma 0. Let's see. Hmm. This should be true. This should be true. What is this false? What is this false? Uh, so it'll come into this. J is equals to star. First thing, I plus 1, j. Second thing, I plus 1, j, which will give us 0. It'll go into this, and this should give us 1. So, okay, this should be returned. Okay, this is done easy. I'm happy that I'm easily doing hard problems now. I'm very happy. Like, it was very difficult for me to do it a few time ago. Like, but ah, now let's memorize this. It's a bool of size m plus one, n plus one. Yeah. Ah, vector of vector bool of memo memo is equals to vector of vector. I should not take off bool because I need minus one also. So let's take it, and at least for like the uh bottom up version. If I want to do the top down, I can take bool then, but right now I need minus one also. The int of first would be n plus one, comma m plus one. Oh, sorry, vector int of size m plus one, comma everything is minus one. Let's start. And a basic answer memorization would be this: if memo of I j not is equals to minus one, return memo of I j, and memo of I j is equals to memo. Just copy this. To run. Cool, it should submit without really, I guess. Uh, why is this false? This will go till the end of this. So only match B, only match E. Why is this wrong? Why is this wrong? I don't want to do. Should be right. What happens if I remove memorization? Does this give me right or wrong? Does my memorization cause a problem? No. My logic is flawed. So if they are equal or P or if they are not equal, then either I can use the power of star, or I can decide to not use the power of star. So if I decide to not use the power of star, okay, this would not be I plus one. This should be I think. Because I decided to not use the power star, so it'll match. Yeah, it should be I. Yes. Okay, so I decide to use it. So I plus one J. I decide to not use it, and I decide to use it just once. Or I can just check here if all of them. It works with 48%. Okay, we have it memoized also, which is good. Now, how do we write a top-down version of this? Because the base case would be hard to write. I think we will have to leave this to this only, the bottom-up version. I don't see a way for me myself to. I know obviously I don't have the best solution out here, so obviously there will be better solutions. But I don't see it myself. I think that's why this is hard. It's easy to write the first version, but it's harder to optimize, I guess. For me, at least for me. How will I write this? Hmm. Let's see the editorial. Recursion and memoization. Yep, that's what I've done. Exactly like me. Exactly like me. We're using just one DP. Okay, I get the idea, but uh, okay. Backtracking. Okay. Hmm, good idea. So backtracking, what they are doing is if both hmm, SID S length, if PID is smaller than P length, if both of them are equal, then SID plus PID, as if PID is smaller than P length, PID is equals to Uh, cool, I think. Move on. DP on stocks. Uh, I'm tired now.